everybody, and welcome to today's Exploring by the Seat of Your Pants Hangout. I'm Sarah, and I'm going to be your host for today. And for those of you who don't know, Exploring by the Seat of Your Pants is all about bringing science, adventure, and conservation to classrooms across North America and the world. And today we have a very exciting guest, Taylor Maddalene, and she will be talking trash with us. We're going to be talking circularity and plastic pollution. And Taylor's background is in marine ecology, conservation, and science communication. And she's been working on projects around the globe with organizations like National Geographic, NOAA, and RARE. Her current research focuses on the impacts of plastic pollution on coastal ecosystem health and tying human behavior and waste management infrastructure on land with what we find in the ocean. So thanks for joining us today, Taylor.
Thanks for having me. I'm excited to be here.
Yeah, we have around 250 students joining us today from around Canada and a classroom joining in from Texas. So hi, everybody. I see everybody coming in on YouTube. And I will let you take it away, Taylor. I'll get out of your hair.
You are fine. Well, thanks for having me on again. I'm really excited to be talking today. Hello to everyone in Canada, in the States, in Texas, Ontario, everywhere that you're coming from. I think that hopefully you'll find this interesting today. I'm excited to dive in, and I'm excited to answer your questions afterwards. So as Sarah mentioned, we're going to be talking trash today, and this is probably one of the few times that your teachers will be totally fine with you talking trash. But we're going to be talking about plastic pollution, circularity, and as Sarah said, a lot of what I do is looking at what we do on land, even in totally landlocked inland locations where I know some of you guys are. To what we see in the oceans and what we find on our coasts and what we find in the water around the world. So before we get into the nitty gritty, I just wanted to give you a quick background on how I got into this space. So some of you can probably relate to this, but as far back as I can remember, all I wanted to do for work was to be a mermaid. I wanted to be in, around, and under the ocean. And then I quickly realized that was going to be a little bit tricky and not a very lucrative job opportunity. So I decided to become a marine biologist. And the sea kind of runs through the veins of our family. The picture on the right is me and my mom. She taught me how to scuba dive. She taught me how to sail. In the top is 3 generations of my family in our happy place, which was by the ocean. And my love of the ocean kind of sent me down this path of science and ecology. Really pushed me to pursue lots of opportunities to travel and to learn, to volunteer, to do internships and things like marine biology and ecology. And all I wanted to do was just explore and ask questions and know more. And I had the opportunity to travel to the Amazon, the Galapagos Islands, to Fiji and beyond. And it made me appreciate the planet in different ways. And it really put into stark clarity how connected everything is and how really more alike we are than we think. And I always come back to this. This is one of my favorite quotes from John Muir. And it says, when we try to pick out anything by itself, we find it hitched to everything else in the universe. If you start studying the ecology of one specific type of bug that you find in your backyard, that could tie you to a bird species that could migrate to South America that's tied to some plant that's only found in this one location. And we are in the middle of all of that as humans. You know, ecology and the natural environment isn't just a separate there that we study. We're an integral part of that. And as I said, the ocean has always been my happy place. And one of my all-time heroes, Sylvia Earle, she was one of the first female marine biologists and oceanographers, one of the first females to go scuba diving. She was really a pioneer in this space. And I had the pleasure of meeting her at National Geographic. But she always says, without blue, there is no green. And so I realized in my studies that, you know, I wanted to dedicate my life to protecting the ocean, my happy place, for somewhat selfish reasons. But I needed to look upstream. I needed to look at the system as a whole in order to protect what I loved. And so my journey from scuba diving to dumpster diving really started when I decided to go back to school and get my master's degree in marine biology from the Scripps Institution of Oceanography in San Diego. And I was doing all of my field work on this tiny island in the South Pacific called Tarawa, which if you were to draw a straight line between Australia and Hawaii, it would be almost smack in the middle. It is in the middle of nowhere in the South Pacific. And when you think about South Pacific remote islands, you think about this picture on the top. You think about pristine white sand beaches and turquoise waters. And you think about the beautiful coral reefs and healthy marine ecosystems, which I was there to learn about and to talk to people about. But when I got there, this was more of the scene that we found. The beaches were covered in waste and trash. And if you were to pick up a piece of this trash, you could see that there were items that were from Japan, that were from the US, that were from Australia. The way that the ocean currents operate, anything that comes into the Pacific Ocean will likely end up in either the North Pacific Gyre or the South Pacific Gyre, which is right near this island. And so I was there to talk about these, pristine coral reef ecosystems, these beautiful ocean systems that were hundreds of miles away from the capital of this country, and that these people would probably never have the opportunity to see with their own eyes. But this was their reality. Plastic was everywhere, and I got to a point where I couldn't ignore it anymore. And so it kind of sent me down this rabbit hole of, how did we get to this place? How did we get to the point where these remote tiny islands in the middle of nowhere are covered in waste from all over the world? So I learned a lot about the history of plastic as a material and the history of consumerism and how we got here. So this graph shows plastic production over time. So it may not seem like a short amount of time to you all, but for me, the 1950s was not that long ago. And that's really when we first started seeing plastic as a consumer product. We had been making things out of natural resources like ivory and cellulose. And we got to a point where instead of using those natural resources, we could make our own materials that were similar, but that we could mold into anything that we wanted. And so production in plastic really just has boomed over the last couple decades. And if you look, that hot pink part at the bottom of the graph is plastic packaging. So that's everything from water bottles, bags, plastic wrappings. It's usually things that are used by a consumer for less than 10 minutes and are then discarded, most often either into the environment or in a landfill, and aren't really recyclable or reusable. And so here we are, we've created this incredible durable product. Believe it or not, these are real advertisements for the 1950s. We created this environment where it was a sign of wealth and prosperity if you could just throw away your dish after using it instead of having to wash it. This advertisement that says the best things in life come in cellophane. And plastic did revolutionize food security and transportation. But all of those characteristics that made it so appealing also make it really difficult to manage at the end of its life. There's not a whole lot that you can do with it after you use it. And so we were just producing more and more and more and not thinking about getting to the point where we find ourselves now. So in 2015, our research group looked into what's happening with all of that waste. And we found that the vast majority, almost 80% of all plastic that's ever been made, ends up either in a landfill or in the environment. So it's either trapped, buried in the ground where it's not really going to break down, or it's out in the environment where it never breaks down. Plastic as a material just gets smaller and smaller and smaller in its fragments, and it never actually properly breaks down. Only about 12% was incinerated or burnt either for energy or for other types of waste. And then only 9%, so less than 10% around the world actually got recycled. And recent studies have shown that there's actually a lot of human impact to plastic pollution. So plastic particles have been found in human blood, in our lungs and our tissues. We know that plastic gets accumulated up the food chain. So because it breaks down so small, it can get eaten by plankton, which then get eaten by bigger fish, which then get eaten by us. And a lot of the chemicals that go into making plastic, so that make it moldable, that make it temperature resistant, that give it all those characteristics, are also harmful chemicals for humans and for reproduction and for our hormones. So everything from the way that we produce plastic from fossil fuels to how we use them to how we dispose them has an impact not only on the environment, but also on us and our human health. And we're learning more and more about that every day. So this is a mashup of different data sets, but for me as an ocean lover, I wanted to know where it was all going. And all of those hot pink spots that you see floating in the middle of the oceans are accumulations of trash and microplastic in the ocean. As you can see, it kind of concentrates in the middle of the major oceans because the way that currents move. And then all those yellow pieces that you see kind of jumping off from the continents are major river systems that are acting like conveyor belts. If you think about the way that a watershed works, if you drop a piece of waste in the middle of the US, even in the middle of Canada, all of that will flow towards a waterway and ultimately to an ocean at some point. And so we know that rivers also play a major role in this. Plastic particles have been found in the air above Mount Everest and at the deepest parts of the ocean in the Mariana Trench and literally everywhere in between. So we're reaching this kind of crisis point where we need to figure out how to turn off that tap, how to turn off the flow of plastic into our environment in the first place. Because once it gets to the point of tiny bits of microplastic floating out in the ocean, it's nearly impossible to manage. So when I was working at National Geographic, we were looking at this. We were looking upstream. We were looking at how we turn off that tap. And we wanted to better understand the role that rivers play. And so we honed in on this data set that showed that from the top 10 rivers, there were only 10 rivers around the world that contributed about 90% of ocean-bound plastic that was coming from the land. And one of those top rivers was the Ganges River that flows through India and Bangladesh, which you can see shown by the little red square here. So in 2019, we conducted what we called National Geographic Sea to Source expedition along the Ganges River. We wanted to travel from the sea all the way up to the source and understand how plastic was moving through this system and what was contributing to it. So we combined exploration, storytelling, education, and even a consumer campaign from the magazine called Planet or Plastic to try to understand this issue better. So we traveled about 1,600 miles from the sea in the Bay of Bengal up to the source of the Ganges River in the Himalayan mountains to look at plastic pollution from a few different angles. So we looked at it from an environmental perspective. So we were looking at plastic in the air, in the water, in the sediment. We were looking at plastic on land. So we were looking at what types of waste were generated, what was the litter like, what were recycling operations like, how was plastic moving through the community. We looked at it from the social aspect. So we were trying to better understand perceptions and attitudes and solutions among societies and communities towards waste and plastic pollution. And then finally, we deployed different types of technology. So we actually deployed what we called bottle tags that were satellite tracked so that we could see the physical movement of different types of plastic waste all the way down the river and ultimately out into the ocean. And we were also using things like drones, underwater ROV vehicles, and other things to better understand the status of plastic in the Ganges. So one of the exciting but also challenging things about working in the space of plastic pollution is that there is no one silver bullet. There is no one single solution that can solve this. There are multiple entry points and opportunities for change, and no single solution can operate alone. All of these pieces need to talk to each other. If you're designing a new material, if you've got a completely recyclable, completely biodegradable material that you produce, that also needs to work with what people know, how people know how to dispose of it. Do they know to put it in a recycling bin? Is there infrastructure to handle it? Does that get separated out when you collect it? Is there a recycling center that can handle that? And ultimately, if it ends up in the environment, what does that mean? And so all of these pieces kind of need to talk to each other. And it can seem daunting, but it's actually a really exciting part of this piece because we need to look at the whole system and figure out how to make that a more circular opportunity so that we don't get it leaking and ending up in the environment in the first place. So I've been saying the word circular a lot, and I just wanted to give a kind of a quick gut check on what we actually mean when we say circularity, because this is something that I study and it gets thrown around a lot. But what do we actually mean? So if you think about ecology and you think about nature, every output ultimately can become an input into the system. The concept of waste is really obsolete in a perfectly circular system. You don't create an output that can't ultimately come back in. Even different types of animal waste comes back in as a fertilizer. When we're breathing, that type of, what gets released comes back into the system through your breath and through the trees and everything. So what we mean with a perfectly circular system is that there is no waste in the first place. And when we talk about circularity in society, this isn't just recycling. Recycling plays a role, and it can do a lot for the system, but it can't be recycling alone. We can't recycle our way out of the plastic crisis. We have to look upstream towards production, and we have to understand what's coming into the system in the first place for recycling to work. And interestingly, cities are sort of complex systems that can be used to optimize circularity. So a lot of my research now comes from this question of, what does circularity at a local city level actually mean? How do we address these multiple intervention points at a local level? And how do we even begin to measure what that would look like? So at our research group at the University of Georgia, we've created what we call the Circularity Assessment Protocol, or the CAP. And this is a methodology to do exactly that. We look at all of those different intervention points along the life cycle of a material, and we try to figure out where are the biggest opportunities to close that loop, to reduce the amount of waste that gets generated in the first place. And to date, we've done this methodology in 56 different cities across 16 different countries around the world, and that is continuing to grow. So looking at the CAP as a whole, there's a bunch of different questions that we're looking at so that we capture that whole system. So the first is, what products are sold in the community and where do they originate? If you go into your convenience store, what are the most common brands that you see? Where are they made? Where do they come from? How do they get to the CVS, the 7-Eleven in your backyard? What kind of conversations are happening and what are stakeholders' attitudes and perceptions? Are people in the community irritated because there's a lot of litter? Are you seeing lots of plastic bags on the ground that really bother people? Do people wish that there were more opportunities for reuse or refill? And what are the product designs that we see in a community? So if you get takeaway food from a restaurant, is it packaged in hard plastic, cardboard, styrofoam? If you want to buy a beverage, if you want to grab a drink to go from your local convenience store, is it usually in PET plastic? Is it in cardboard? What does that look like? What are the material types coming into a community? And are there opportunities for refill and reuse? Can you go to maybe a big grocery store and get a concentrated thing of dish soap so that you don't have to buy packaging after packaging? Are there opportunities for you to bring your own container to refill things? What does collection look like? Is there household recycling and waste collection available to everyone in the community? Are there ways of managing that waste? Is there a recycling plant? Is there a landfill nearby? Is there maybe a waste to energy plant or even composting available in your community? And then what ends up escaping that whole system and ending up in the environment as litter? And for everything that we look at as litter, we can say, how did it get there? Why did it get there? And how do we stop it from getting there in the first place? Is there a waste management system that's available for it? Is it not getting collected? Is it because of what it's made of? Is it because of the community's understanding? Where in this whole life cycle can we tap in so that it's not leaking into the environment in the first place? And what comes out of this is a lot of words on a slide, I apologize, but what comes out of a CAP is a series of opportunities for a city based on all of those different components. And what that gets turned into is an intervention. So the city can actually take that data and say, we really want to enhance our recycling program, or we really want to just ban styrofoam containers from our restaurants. And they can actually put that into effect. And actually, anyone in the world can help us with that litter, with the leakage section of the CAP, because we have what we call the Debris Tracker app. This is a free open source citizen science tool that we've used to log over 8 million items on every continent around the world. And it's an easy, kind of fun way just to document what litter you find in your own backyard. You kind of go through and virtually add things to your trash can, and then that immediately gets uploaded to our website. So you can go on to debristracker.org and actually see all of the litter data that's been collected from, you could zoom into your neighborhood, or you could zoom into a spot near a research station in Antarctica and see what kind of litter is being collected. This is actually just a snapshot of data from the last 6 months of the Debris Tracker app. As you can see, plastic comprises about 3/4 of all of the litter that we see around the world. And the most common items are things like food wrappers and hard plastic fragments and foam fragments. So these are things that we know are difficult to collect, are difficult to recycle, are really abundant, and might not be necessary in some places. So what we see downstream can actually help inform the solutions that we need upstream. So I just want to leave you with a quick list of what can you do. When I was growing up, it was the 3 R's: reduce, reuse, recycle. Now we also have refuse. In some places, it's even 6 R's. But really think about, your first step is kind of eliminating the things that you don't necessarily need. Maybe you don't need to get the silverware when you're getting your food to go. Maybe you don't need to get a straw when you're getting a cup or a beverage. Refusing and rethinking what we're doing is a first key step. Get involved. There are volunteer cleanups all over the world, and stay up to date with current research. Maybe you could even start a club in your school. And use your voice. You guys are the next generation of leaders, and you can use your voice to inform others. You can write to your government representatives. You can submit, you can use social media. You can highlight the stories in your own location. Never underestimate that people do want to hear what you have to say. Citizen science, you can use our app, or there's lots of other citizen science things out there if you want to get involved in actually collecting data and making a change in your own community. Always remember the power of the consumer. Every choice that you make as a consumer is a signal to the economy. So the choices that you make do make a difference. So be, as much as you can, be a responsible and sustainable consumer. Know what you're purchasing and where it's coming from. Know your waste. This is one of my favorite ones. There is no away. So when you throw something away at your house or in your school, it's going somewhere. Do a little bit of detective work and figure out, where is that actually going? Where's your recycling going? Where's your compost going? Be curious, and that'll make you a better steward of how you're disposing things in the first place. And last but not least, just stay curious. This is a really important one. There is no one solution to the problem of plastic pollution, waste, circularity, and all of the ways that this ties to community resilience, sustainability, and climate. So keep asking tough questions and keep an open mind about how you can make your future better. And with that, I will pass it back to Sarah, and I am always available for any questions that you have. There's my email, there's our website. Please stay in touch and feel free to stay curious and ask me questions too.
Amazing. Thank you so much for that, Taylor. I learned so much just seeing some of the images that you had there. And I feel like sometimes when I listen to stuff like this, I'm wondering, what can I do and how can you start? And it's so great that you mentioned to just stay curious and then become aware of the plastic that's being used in your day-to-day life, because this is something that we're all in touch with. And the first step is just becoming aware of what you're using and just being more mindful and realizing that you're part of that process. So really great conversation. Let's get started with the Q&A. I know we have a few classrooms joining in on the YouTube chat, but we also have a couple of classrooms joining in behind the scenes here. So I'm going to bring those folks in first. Let's bring in Mr. McGill's class. They've been waiting with us since the beginning. So I'm going to bring you guys up if you have a question.
Why do we only recycle 9% of plastic?
That's a really good question. So if you ever look at a piece of plastic, usually on the bottom, there's a little triangle and there's a number inside it. That tells you the type of material that it's made of. And there's actually really only 3 material types that are super recyclable. So that's number 1s, number 2s, and number 5s. And so that's things like plastic bottles, like the big jugs of, washing fluid and things that you buy. But most plastics are things like your chip bags or your, different types of plastic wrap that come in packaged things. So that's a lot of the stuff that gets used, and that's actually not recyclable. So it has to do with a lot of how it's designed. A lot of the things that are coming out onto the market aren't actually recyclable. So if you look for that little number on your plastics, it's really only the 1s, the 2s, and the 5s that are mostly recyclable. There's lots of other things like styrofoam that's just not usually recyclable. So some of that stuff is just not getting collected and not getting processed.
Interesting. There's always these little signs and
I know.
things to help you that you just have to know what they mean. I think that's the next step. Is there any more questions from Mr. McGill's class?
I had one that was, is there a recycled or repurposed product that you're really excited about right now?
That's a good question. There are some places that are doing plastic bottle deposits. So they're trying to take back like Coke bottles or Sprite bottles or Pepsi bottles and then turn them right back into bottles. Usually recycling that can go right back into the same type of product is more viable than something like turning it into, something that's not as usable. But recycling is being used to build, benches and furniture. People are using it to make clothing. So there's a lot of different opportunities, but usually for me, this is going to sound really boring, but the ones I get most excited about are when they can put it right back into that same product. Because if you think about it, all of the Coke bottles that we put out there in the world, if we could just take them all back and put them right back into Coke bottles, that would be an instant supply chain. Awesome.
Okay, let's jump to a question that's kind of similar from our people joining us on YouTube. They want to know, how fast does plastic biodegrade?
It's a good question. So it's kind of a trick question because plastic doesn't actually biodegrade. So typical plastic is made from fossil fuels that just breaks down into smaller and smaller pieces. There are things called biodegradable plastic or compostable plastic, but those actually still need to be processed in a special facility. So even if you see compostable plastic, if you leave it in the environment, it's not actually going to degrade properly. It will just break into smaller and smaller pieces. Because of the way chemically that fossil-based plastic is made, it can't actually go back down into its natural constituents when it's out in the environment. So plastic, as a material, as a recognizable material, will last for hundreds of years. I think plastic bottles can last, up to 500 years, looking somewhat like a bottle, but then eventually they'll just break down into smaller pieces. And those little we call them microplastics, can last forever. We haven't been around long enough to know if they'll actually really go away. But as far as we know, they're going to be there forever.
And I think also there was another question from the same person where it's more, how does biodegradable plastic degrade? So I'm thinking
Good question.
Yeah, compostable bags.
So yeah, if you see compostable plastic, it still needs to be composted in a special facility. So compostable plastic, if you heat it to a really high temperature, then it will be able to break down. But if you leave it out in the environment, that's not going to really be the right situation for it to break down. So if you put it in something called a industrial composter, so like a professional industrial size way of composting it, then it can break down pretty fast. That can be done in a matter of days if you've got the right situation. But you have to make sure that it gets into a compost bin. So when you throw it out, it needs to actually go to a composting facility, just like if you were to throw recycling in the recycling bin and then it goes to a recycling plant. But if it gets there, then it can be broken down really quickly. But it's not going to break down in the environment, which is something that's super confusing to people. Because a lot of people will just see biodegradable and they'll think that it can just break down in the environment, but oftentimes it can't. it still has to go through the waste stream.
So it needs unique environmental conditions to be able to effectively break down.
Yep, exactly.
All right. All right. We have another classroom joining us. So we have grade 4s. I see someone's kind of ready to jump up with the question, so I'll bring you in here. Go ahead.
Did you help out clean the beach that you showed a picture of?
Yeah, we did. So we tried to do a big cleanup of that beach. I've done lots of beach cleanups in lots of different places around the world. And it's really important to do because we have to do something with all of the trash that's already out there. The tricky thing is that usually those will just get dirty again in a really short amount of time. So we have to make sure that we're cleaning it, but then also looking at what we find and figuring out why did this get here in the first place? And how do we stop that from happening? So yeah, we did do some good cleanups down there in the South Pacific, but believe it or not, plastic and trash still ends up down there.
Hi.
Oh.
Can you say?
Yeah, I had I spent some time near the ocean over the last few years, and because there's so much plastic within the ocean, whenever there's a change in weather or there's a big ocean swell that comes up, it seems like it brings more plastic after you've done some cleaning. It actually brings more plastic up, and then there's all these different types of plastic on the beach all over again, even after your last cleanup. So it's a continuous process. And I had noticed that when I was spending some time in Nicaragua, there was a lot of the plastic that I had seen walking along the beach was more bathroom hygiene. So a lot of shampoo bottles, razors, toothpaste bottles, things like that too. So a lot of the products that we're using on a day-to-day basis are the things that are kind of, coming up that you're not even thinking about.
Yeah. Something that's kind of fun to do in a classroom is if you keep a daily diary, just try one day and see all of the things that you touch that are plastic. Start with when you wake up in the morning. Is your toothbrush or your toothpaste? Do you drive a car to work? What about the pens or pencils that are in your classroom or the chairs in your classroom? It's everywhere and it's important. There are durable plastics that we really need, but like Sarah said, those aren't necessarily, you're not going to see a chair or something like that ending up littered, in your backyard all the time. So look at all the things that you touch in a day that are plastic and then see, what you're seeing as litter. And it's really interesting to draw those comparisons.
I see there's another question here ready to go. I believe you're muted on your end, so I think you guys have to go through that.
Perfect.
Where do you put all the garbage when you clean it up?
It's a good question. So a lot of the time that has to go to a landfill. So we try, if we can, to recycle it. So if there are things like cans or glass bottles or, even some plastic bottles that we can recycle, then we will. But usually if it's been out in the environment for a long time, it's got stuff growing on it. It'll have like algae or it'll be dirty, and that's not great for recycling. So most of it, unfortunately, we have to throw out. So it's just got to go into a landfill.
And I think a lot of the idea too is just to take it out of that almost circulation of the water as well, and kind of containing the plastic, which relates to one of the questions that has come in from one of our YouTube viewers. They had asked, how do plastic bottles or shampoo bottles end up in the ocean? So what's the process behind that?
It's a good question. And it's something that we're still looking at. A lot of those kind of sources and pathways are we're still trying to figure out, but there are lots of different ways. So depending on where you are in the world, sometimes that those kind of the waste will get collected, but it's not really buried properly. So if you think about a landfill, usually the process is that it gets brought to a landfill and then it gets buried. So it's not going to, if there's a heavy rain, it's not going to flow out. But in some places, those aren't as well maintained. So if it's just sort of like an open dump or a landfill that isn't managed well, sometimes plastic is so light. So if there's strong winds, if there's a heavy rain, that can just kind of wash it into the closest body of water. And then, like I said, any body of water, it has the potential to make its way out into the ocean. So it could be the case that it has been collected, it has been disposed of, but it just isn't properly caught in that system. And then there are some places where littering is the only, not necessarily littering, but open dumping or, not collecting trash is the only option that some people have. And so that'll still, again, end up in the environment, and then it'll get washed into a closest waterway. And every waterway, one way or another, if it's moving, will flow into the ocean. And then it will ultimately get there. And then once plastic gets into the ocean, it's really difficult and really expensive to collect. So once it gets out there, when we had those bottle tag trackers in the Ganges, we could see it go all the way down the river and then flow out into the Bay of Bengal and get caught in little eddies and circulations and ultimately make its way all the way out to the Indian Ocean. And then it's really difficult to catch and collect.
A really long process.
A long process, yeah.
Great. Well, I think we're kind of coming up on time soon, but I wanted to see if there was any more questions that our classrooms behind the scenes might have. Mr. McGill's class, I don't want to bring you guys up just in case you don't feel like being on screen, but if you can give me a thumbs up if there's another question, we can come back to you, or we can just start moving forward. All right, I feel like there's no questions coming in from there. So thank you for your time today, Taylor. This was a really great conversation. I know I learned a lot. I hope the other classrooms learned something. And you had mentioned too, I think on your last slide, there's some more ways for anyone joining here to get some more information. So if anyone's interested, you can, look at those up. And I see the classroom wants to say a goodbye and thank you. I see some people getting up, so thank you so much for joining. Perfect. Thanks, guys, for joining. Thank you, Taylor, for your time. Thank you for everybody joining on YouTube. And yeah, let's keep the conversation going about plastics and how we can all be part of the solution here.
Thanks, guys. Have a great day.